Alright, so we're going to solve some equations today. And again, you've done this before, but we want to review some basic principles. In algebra, think of this equation, the equal sign, the two sides are balanced. So whatever I do to one side, and when I say that one side or do it to both sides, I'm talking of the equal sign. Okay, so basic equation here. 3x plus 14 equals 50. Our goal is to figure out, well, what could we plug in for x here to make this true, right? And so common strategy, we say we want to isolate the variable. We want to get x by itself. And so let's go through some operations. First, let's subtract 14 from both sides. And again, I hope this is feeling really familiar. So 3x equals 50 minus 14, that's 36. So now 3x equals 36. It's really the same equation, we're just manipulating it, changing it up a little bit. Again, our goal is to get x by itself. Well, these are multiplied together. 3 times x is what this means. So how do you undo multiplication? Well, you're going to divide. So we're going to divide 3 by both sides. And of course now x would equal 12. And again, I know that's pretty basic. I hope you're saying, hey, I understand this. I hope you do. But we just want to kind of revisit a couple things. What about this one? Okay, it looks a little more intimidating. We've got a t, that's our variable, and it's on both sides. Also got some parentheses and things. So let's just clean it up. The strategy's the same, except where you've got the variable in multiple places or both sides of the equation. You've got to combine them ultimately. So let's march through this. To help us, there's different strategies, but let's go ahead and just distribute, get rid of those parentheses. So let's take the 6 through. So I would get 6t minus 12, and all I did there is 6 times t, 6 times negative 2, right? And same thing over here, let's take the 2 through, so 18 minus 40, distribute there. Now, let's get our t's on the same side of the equation, so it's negative here, so let's add 4t to both sides. And while I'm at it, let's take this 12 over. Since I've got the t's on the left, let's take my numbers over. So I'm going to do the opposite. I'm going to add 12 to both sides. So 6t plus 4t, of course that's 10t. Negative 12 plus 12, that goes away. 18 plus 12, that's 30. Now, very similar equation, right? Basic to solve. Let's divide. And so t is going to equal 3. Hey, we're good to go. What if I run into an expression like this where I have more than one variable in an equation and they say, hey, solve this. This is area of a triangle, by the way. Solve this for h. Well, I don't know b or h or a. So your answer is not going to be some number. They want you to simply rearrange this equation, get h all by itself. Okay, and we do that a lot of times. So think of these other things as numbers, I guess, but just rearrange it. We're going to get h by itself. Well, how would I get h by itself here? 1/2 is just a number. B is some number, right? I don't know what it is, but these are multiplied together. How do you get rid of something that's multiplied? You divide. So I'm going to divide 1/2 b by both sides. So 1/2 b by both sides. So h would equal a over 1/2 b, which would be perfectly acceptable. Now you do have a fraction on the bottom. That could be a little awkward, so here's another way we could write that. That would be the same as a over b, and then dividing by a fraction, remember, same as multiplying by its reciprocal. So I could write this as h equals 2a over b. In fact, this is the way I would probably prefer to write it, but this really means the same thing. Okay, I want you to feel comfortable with either one. How about this one? Volume equation. Solve v for h. So again, let's see h by itself. Pretty straightforward. Well, pi is a number, r squared here, so I'm going to divide pi r squared by both sides. So h equals v over pi r squared. And now there's no numbers to manipulate or anything like that, so there you go. Just rearranging for a general equation. How about a couple word problems, right? These always kind of bother some of us. Hey, some basic strategies. Sometimes sketch a little picture to help you picture things. Try to come up with an equation. Just think your way through it. Don't be intimidated when you see these words. Two buses leave Houston the same time, travel in opposite directions. Okay, so I got a bus going that way. I got a bus going that way maybe. Maybe I call this bus A, this bus B, and let's say here was Houston right in the middle, okay? One bus averages 55 miles per hour. So let's say bus A goes 55 miles per hour. The other one goes 45. Well, that's painful, right? 45 miles per hour. When will the buses be 400 miles apart? Well, that sounds kind of intimidating, but it's really not. Let's think about it. Bus A, here's a little equation we know. Distance equals speed times time, or rate times time, right? So this bus, bus A is going to be 55t is going to give you its distance. So bus A has a distance of 55t. So if I plugged in 1 hour for t, it'd go 55 miles. 2 hours, 110 miles, so on and so forth. Well, bus B is going to be 45t, isn't it? So I'm going to add these together. And I want that distance. Remember, this is distance of bus A plus distance of bus B. When are those two distances combined? Going to be 400 miles. Hey, I got a basic equation now. That's easy to solve, right? Combine like terms. So 100t equals 400. Divide, get your t by itself. Whoa, I'm not dividing by t. Sorry about that. I'm dividing 100 to get t by itself. And so t equals 4 hours. So in 4 hours, those two buses are going to be 400 miles apart. Again, hopefully you can kind of follow that. Not too bad. One more. You're building a triangular garden in your backyard. You want the length of the sides to be in a 3:4:5 ratio. So you want something like this. So you want like a 3 and a 4 and a 5 on this side. But it's not going to be like 3 feet, 4 feet, 5 feet necessarily. So let's just put an X for each of these. So they are going to be that ratio. If you put a 1 there, it'd be 3, 4, 5. Put a 2, it'd be 6, 8, 10, so on and so forth. The perimeter, remember perimeter just means you add up all the sides. We want it to be 18 inches. This isn't a very big triangle. You're building a triangular garden and you want to 18 inches. This is like a little tiny thing. So anyway, it's kind of a silly problem, but we'll solve it. Find the lengths of the sides. Well, we want 3x plus 4x plus 5x to add up to what? 18 inches, don't we? So let's do that. Combine like terms. So 7 plus 5, so 12x equals 18. Let's divide that 12 over. And so x equals 1.5, right? If you just did that. 1.5 inches. And then you just multiply each of these. So 3 times x, so that would be 4.5 inches. That would be one side. 4 times x, that would be 6 inches on the other side. And 5 times x would be 7.5 inches. So there would be our lengths. If you're wondering like, whoa, where do those come from? Just plug them in a calculator, right? So you can just do 1.5 times 3, 1.5 times 4, 1.5 times 5. Hey, you're good to go. So again, just solving basic equations. Again, really encourage you, even though it's online, write things out in your notebook. Solve things, do the work. It's going to help you visualize, it's going to help you be in good shape.